Hello friends, how are you? Hope you enjoying these videos where we are trying to explain these concepts with some different manners. So once again I would like to say welcome back to Misostudy video classes, and again I am coming back with this new video, that is Motional EMF. Now what exactly this Motional EMF? Actually, if you try to recall, then during the discussion of induced EMF, I explained you two Faraday's laws. Fine. So, what were those Faraday's laws? One was, if the intensity of the magnetic field is changing, then induced EMF will come into the picture, I mean in the coil. And second was, if there is a relative motion between coil and magnet or the source of the magnetic field, then induced EMF will come into picture. So, this motional EMF is associated with that second assumption. Fine. So, simply I think it is better to mention those two simple assumptions, that is Faraday's experiment. Fine. So, on the basis of this Faraday experiment, one term was change in magnetic field intensity B, and second is, that is what? Relative motion between this coil and magnet. Now, magnet means basically if the magnetic field lines or flux is changing or cutting, then this second point has relevance for this motional EMF. Exactly what we want to discuss, that is, say for example, simple thing. Let us say this earth has magnetic field, fine, north to south. So, there are two components of earth's magnetic field, one is horizontal, another is vertical. Now, let us say this metallic rod, assume that this is not a orange color chalk holder, but it is a metallic rod. Now, if this metallic rod is moving like this, then vertical components of earth's magnetic field will cut. So, due to this variation, due to the cutting of the magnetic field lines, some induced EMF will come into picture at the ends of this metallic rod. So, the idea of motional EMF is this way: a conductor is moving, magnetic field is present, magnetic field lines it is cutting, and then what is happening on that we want to discuss. So, this is the basic concept associated with this Faraday's laws, and entire story is coming out from this particular experiment only. Fine. So, let us imagine a situation. Let a metal rod of length L is moving in such a way that it is cutting BV, that is vertical component of Earth's magnetic field, VB. In bracket I can mention Earth. Fine. So, just take a look. Let a metal rod of length small l is moving in such a way that it is cutting BV, Earth, that is vertical component of Earth's magnetic field. Then at the ends of rod EMF, simple term, will appear. Okay, means a potential will be developed. EMF appear means like this. This is one situation. Another situation, I think I should mention it as 1. This is one situation. Second situation is like this. Say for example, this is a zone or region where magnetic field lines are like this, that is perpendicular to this green board inside. Okay, no problem. Let us say it is B. Fine. Now, I have a coil, rectangular coil, say for example, this way. Okay. And it is moving with velocity v in this direction. Now, this coil is made up of, let us say, copper. Copper is a conducting material. So, inside this copper there are free electrons, nice. In this metal rod also free electrons. So, two things are common in both these examples, they have free electrons, fine, no problem. Now, when it is moving with velocity v in this direction, flux is changing. Over here this vertical component is varying, cutting. So, because of this reason, let us say the electron is here, this red color minus sign is electron, actually it is inside this wire, but just to show you I am picking out the electron, putting over here, fine, just to show you, otherwise inside the wire it is difficult for you to visualize. So, this electron, fine, actually QVB, Q is the charge of the electron, QVB act in this direction and QE will act in upward direction, fine. Now, in both these examples, induced EMF will appear over here. Let us say name of this rod is, I think I should use this color chalk, that is A, it is B, it is C, it is D. So, A, B, C, D is this coil. Okay, it is moving in this in this direction. So, on the electron this FB magnetic force, it is electric force. Okay. So, in both these examples it is sure, we are clear that free electrons are available. Okay. In both these cases, free electrons are present, and you can say the velocity of these free electrons is similar, with which either this coil is moving or that metallic rod is moving, fine. So, in both these cases free electrons are present and moving with velocity v. V is the velocity of this coil or of this rod. So, magnetic force is acting, fine. So, for this electron, fine, for this electron, we can say F is equal to minus QVB. Sin theta I am leaving out. So, F is equal to minus QVB is acting, fine. But now in this diagram I mentioned that QVB magnetic force is in one direction and FE is equal to minus QE. The same approach is true for metallic rod or for this coil. Okay. So, now from Lorentz force equation, I think I should mention this term, from Lorentz force equation, what we can say, just use this space over here because it is available. So, I am using this space, that is FB is equal to FE. So, it will give me E is equal to VB. Okay. But take a look over here, is equal to V is equal to ED, fine. So, this induced EMF, electromotive force, is equal to electric field upon this length, replace the values. So, induced electromotive force is going to give you VLB, fine. Basically, this is the equation for which we are looking in terms of this motional EMF, that is this EMF is equal to velocity, length of the conductor and magnetic field present, VLB. That is very useful formula. So, now from starting, let me summarize these points, fine. Then we have to move ahead for some other parameters, fine. So, we started this motional EMF, fine. I mentioned two cases so that it is going to be easier for you to understand. Case number 1 is, let a metal rod of length L is moving in such a way that it is cutting BV, that is Earth's magnetic field, vertical component of the Earth's magnetic field. Then at the ends of rod EMF will appear, one case. Second case I mentioned, let us say magnetic field is present perpendicular to this green board. Okay. Now, perpendicular to this green board and then a rectangular coil is moving with velocity v in this direction. So, the force acting on the electron, rather the force is acting from the Lorentz force equation. Okay. So, then I mentioned in both these cases free electrons are present, obviously, because they are conductors and moving with velocity v. Well, v is the velocity of that particular conductor in which these electrons are present, fine. So, magnetic force is acting and that magnetic force I mentioned for this electron we can say Fv is equal to minus QVB, minus sign is because of this negative charge on electron, and Fe is equal to minus QE. From Lorentz force equation we can say Fv Fe, and then equating these terms with the, you can say, potential also. So, induced EMF is nothing but representation of that. So, we will get this relation induced EMF is equal to VLB. This is defined as the motional EMF. Now, moving ahead for this particular explanation, but before that I have to clean this green board for you. Okay. And this entire process is very simple. So, my simple suggestion to all of you, just take a look of these explanations once or twice and you will find yourself in a comfortable position. Okay. So, the space now coming to us, we will use it for explanation of further concepts associated with this motional EMF. Okay. Now, some examples, some practical examples I want to mention about this motional EMF. Now, how you can practically consider these cases? Say for example, practically considering the situation of motional EMF, you can say there are two good examples. One example is, these examples I am picking so that you can get the better picture. Okay. Example 1, that is aeroplane flying. Okay. The flight is going to New York, say for example. Now, this is the curvature of the earth, and obviously magnetic field lines are vertical component of the magnetic field lines are present. Fine. Now, if the plane is moving in this direction with velocity v, so the look of the plane, if you observe from the top, you will find it's like this way. Okay. Means wing span, this, let us say it is for total distance L, and it is moving with velocity v and magnetic field B is present. Fine. So, now for this plane, if I am writing that this relation is true, so basically what is the meaning of this relation over here? Fine. So, let me allow to write down this particular explanation. Fine. Actually, what will happen? The situation will be like this. Fine. And this length is L. So, you can say on the body of the aeroplane a type of potential will appear. That is why the tires of the aeroplane are slightly conducting in nature. So, when it touched down, the entire, you can say, charge developed because of this reason, because of friction forces, it gets transferred into the earth. Fine. That is why some shot of smoke you can easily notice while touching down the ground. It is one reason. If the tires are not conducting, then movement, the first person will come, the current will pass through that person. That situation is going to be very difficult for that particular person. So, this is one example. Another example that I want to mention is motion of fuel tanker. These are very simple examples I am picking. You can notice these examples in your day-to-day life. I am sure you have some time noticed oil tanker, fine, mentioned like IBP or Bharat Petroleum, something like that, is moving, and on the back of this vehicle there is a metallic chain hanging and touching the ground. If you till now not noticed, try to notice it. Now, why it is so? Okay, let us first try to understand. See, there are minimum 2 set of wheels in this tanker. In front there are 2 wheels, in back there are 2 plus 2 4 wheels. Anyway, we are not interested in the wheels, we are basically interested in axle. Okay. Now, what is this axle? This axle is a metallic rod, fine, and in this metallic rod wheel. So, there is a set like this. Another is in the back side, wheel, set of wheel, wheel, set of wheel. Anyway, and this fuel tanker is moving with velocity v in this direction. Now, who is going to create the problem? We are watching from the top. So, vertical component of the Earth's magnetic field is out. So, what is happening on? Let us say the length of the axle is L. So, when it is moving, magnetic field lines like this and it is moving like this. So, they are cutting. That is cutting of magnetic field lines of Earth's perpendicular this vertical components of the Earth's magnetic field. Okay. So, the metal rod is axle, metal rod will cut VV. What is VV? Vertical component of Earth's magnetic field. Fine. So, if it will cut like this, then what will happen? Then we can say VLB. So, this induced EMF will appear on the ends of this axle, at the ends of this axle. Ultimately, it will start producing charge accumulation, and this fuel tanker, if carrying petrol or diesel or any inflammable material, so what will happen? Dangerous situation. So, this metallic rod which is touching the ground, that is small chain, sorry, not rod but a small metal chain from the body of this oil tanker touching the ground, what will happen? It will keep on passing the excess charge or potential to the ground. Fine. So, this way you can save your this fuel tanker in order to face any difficulty. That is one very good example, very simple example. So, from now onwards when you are moving, try to notice this thing. Fine. And it is not for beauty purpose, it is for this purpose. Technically it is for this purpose. Okay. Now, this particular concept and this formula, in your board exams and school exams, you are supposed to get at least one good question based upon this idea. This simple explanation, derivation, let me tell you, they may ask you one or two practical examples, fine, from your day-to-day life. So, you can mention like this. Now, I would like to discuss a numerical for this particular situation. I think that will give you also some understanding of this very good and simple concept of motional EMF. Now, consider a situation. It is a, you can say, problem or numerical. Okay. So, let me try to give some words to this situation. A train moving north south with V is equal to 108 kilometer per hour. Okay, fact number 1. Fine. Fact number 1. Fact number 2, axle is equal to 2 meter. Axle means the metallic rod connecting two wheels of the train, that coach. Fine. Axle is equal to 2 meter. And third fact is VB is equal to 8 into 10 to the power minus 5 Weber per meter square. Fine. And final fact is, there are 64 axle. Okay. 64 axle means 2 axle means 2 wheel. So, 64 means 30, 1 coach 4. So, it is like that, this much coaches. It may be a goods carrier. Fine. Now, simple question is, what is the induced EMF on single axle? Then what is the total induced EMF? Multiply with that 64, and sometimes they may ask you total charge accumulated, Q. Fine. So, find total EMF. Total EMF means on all axle. So, what I should do? I should calculate EMF for single this coil, that is axle, that is VLB. Okay. Now, V is how much? V is equal to, it is given in kilometer per hour. So, obviously you have to convert it in meter per second. Fine, MKS system. So, it is 108 into 5 by 18. So, that will give you 6 and 30 meter per second. Okay. So, induced EMF on single axle is 30 into 2 into 8 into 10 to the power minus 5. So, how much it is going to be? 8 to just 16, 16 3s are 48, 48 and 0 into 10 to the power minus 5, or you can say 4.8 into 10 to the power minus 5 volt. Now, for 64 these axles, it is 4.8 into 10 to the power minus, 2, it should be minus 3, 4.8 into 10 to the power minus 3 into 64. Fine. So, that will give you the result. So, this is the total charge accumulation that is taking place. So, practically this concept is very important. Fine. And this entire discussion, a short discussion, but I hope it is interesting for you to understand these concepts of motional EMF. I tried my best to make it more simple and easier for you to understand. So, students, finally, I would like to suggest all of you at least twice or thrice revise this video with previous videos. Fine, because all videos 1, 2, 3 and this one I think 3 or 4, that is, they are in continuation. Fine, this is a story in the chain format. So, if you revise all these videos in totality, you will definitely able to develop some better conceptual clarity of the topic. So, with this positive suggestion, I would like to request all of you, please keep revising, take care of yourself, that is very important, and get associated with Misostudy video classes. Once again, I would like to say thanks to all of you for watching the video, but again I will come back very soon. Thanks a lot.